Hi guys, this is Nitin, and in this video I have some special demo for you guys. I have been always fascinated about SAM, which is Segment Anything model by Meta, and its various capabilities. I have been heavily using it in all of my workflows, and I have been intrigued by one of the tools inside Roboflow, which allows you to point and click anywhere in the image, and then it lets you generate the polygon for those objects. This basically allows the annotator to easily annotate complex objects without having to manually click and generate the whole polygon by clicking on each and every point outline of the object. Now, SAM is very capable, and recently we have SAM 3, but SAM is already a capable model, and its point and click feature is like superb from the version 1 itself. So if I show you how it works, then basically we have an image encoder which generates the features or attention mask for the image, and then we have an prompt encoder which either takes a bounding box or a point and then encodes it into the same space, and then that information is used to generate masks. If you can see in this demo video, the authors have really put a lot of details into the demo. Here we have 2 points, which is on a ball and a dog, and the SAM model basically generates a mask, and then it also in the latest SAM 2 and SAM 3 follows it throughout the video. But we today we are going to talk about the point and click method so that it can be utilized to generate the masks or polygons for our annotation tool. So before I move forward, let me just show you a small demo how it works inside Roboflow. So this is Roboflow dataset annotation tool. I will click on one of the image. Let me load this one, and let me just delete these quickly so that we can start with a fresh demo. So as you can see on the right side, we have this smart select, which is powered by SAM. And the way it works is for the first time, if you move your cursor, you will see it is kind of highlighting the objects of interest in red area. So this is SAM doing its work, basically giving you a suggestion about if you click at that point, the polygon is going to be generated for that particular object. And SAM is smart enough that it is able to segment even tiny details inside the image. So let's suppose I have to annotate this helmet here. So what I will do is I'll just click here, and then it will generate a polygon. If I finish it, then basically this and helmet is annotated now. So as you can see, it has a lot of points. If a human annotator has to do it, they have to click on the contour of the helmet to complete the annotation. But here with a single click, it is able to segment it. Now let's see how Roboflow is handling it. So if I go to Networks tab and again click on this tool, you will see every time I move my cursor, it sends a request which is segment image to the API at this endpoint. And what it sends as a payload is the click, which is the X and Y position of the cursor, so that SAM can generate a mask and then return polygon. And in response, it returns back the polygon for that particular area which we see here highlighted. Now there are other advantages as well. If you let's say click on this one but it does not gives you clear points, then you can click further, so it will enhance the overall polygon and cover the whole object. And if there is some additional coverage which you don't want in your object, for example this face area, if I click here, it will also use it as a negative point to remove those areas. These are just positive and negative labels which is passed along with the points so that SAM can generate good quality masks and allow you to refine the polygon for annotation. Now I wanted to do something very similar into my own annotation tool. So for guys who don't know about it yet, I am working on my own in-house annotation tool, which is going to serve for a lot of use cases. For now, the interface is very similar to Roboflow, and if I click here, you can see this is the image annotator. We can move around, we can zoom in, and let me see. So this one we had the polygons here. Okay, so if I want to annotate this particular product, what I can do is either with a simple annotation, I can draw boxes around it and select product. Okay, this is a product. Or in Roboflow use case, which we just saw, we were generating polygons. So the way would be to point and click everywhere so that a good quality polygon can be generated. But basically, to improve or speed up on annotation, we should have features something like similar to how Roboflow implemented it. That is, when we click on an object, it should be able to generate the polygons around that area. So my approach for this had been to I can go onto this point and click tool, and it is generally used to create annotation which is point based. For example, if I click here, it will add a point. By the way, you can see it here. Inside product, you can see these two things. And other approach is, if I want to have polygons, I should have this activated, which is AI assisted annotation. I know it is complicated right now, but I will have to improve this. So the idea is, when I select this as a polygon tool from point, and if I click somewhere here, it should send the request to the server and then get me the polygon. Now this is itself is a complicated task. Reason being because I cannot keep the SAM model into memory if a lot of people are using it, and I cannot generate the polygons for the image because the inference has to be done on the server side, and I don't want to pass this image, which will be like 4 or 5 megabytes, to go back to the server, generate the inference polygons, and then send it back to the client side here so that it is visible in the browser and people can interact with it. And other issues are like the bandwidth issue. So if the user is on a limited network bandwidth, then it will take a lot of time to send and receive images back and forth if they are playing around with it and then trying to do it at multiple times. So I was trying out a simple approach where my idea was to encode the image only once and then keep it inside something like in memory, like Redis on the server side. And whenever a user uh, sends XY coordinate of the image, instead of inferencing and generating the features again for the image, we would be only generating the mask, and the image feature will be already calculated and stored in memory, so that the GPU is freed. It does not have to infer with the whole image for feature generation, and then the responses can be very quick so that user can quickly interact with it. So I have this small demo here. This is running inside the Docker environment, by the way. So first line basically installs segment anything to repository as a Python package from GitHub, and then we do these imports, and then I have this small utility class implemented here. What I do is, I have this SAM2 model inside this class, and whenever we want to generate feature of an image, we call the encode image function, which generate the image features and then returns it. And then whenever we want to predict a mask, then it takes those features and then compute the masks. So it does not have to pass the image again. I mean, if you see the default demos what SAM provides, you will have to pass the image predictor like this, using the set image function, and then you can generate the mask. But here in our case, we do these things separately and then we store it in memory, so that whenever next time we want to generate a new polygon based on a given point, we will be able to do it very quickly. I've tried this on CPU, it works good. And I'm using tiny model because if you give enough points, the model is smart enough that even the tiny model is able to generate good quality masks. So here I initialize the instance of this SAM model, and then I load this image. Let me show you what the image looks like. So this is a simple retail shelf image, and when I run this cell block, basically it reads the image as an RGB and then passes it to the SAM encode image function so that we get the image features. And as a prompt example, what I have done is I opened this inside this jspaint.app application, where I can uh, go here, and then if you see at the bottom right corner, you will see the coordinates. So I know for demo purpose right now what coordinate do I need to pass if I want the point to appear here, so that Sam can generate a polygon for me. And label here is 1. Basically this is a positive label, so it will use it to generate points. If I pass nearby points as a 0, which means I don't want the SAM to include those area during polygon generation. It's as simple. I can pass a list of prompts here, and when I call this, basically it puts a point here, and then if you see this green area, this is what the SAM generated as a mask. And I think you may have seen these in demo videos, demo on SAM website as well. It's the same thing, but the idea here is that we compute the encodings only once, and then we can just reuse it every time with the same feature, and that basically improves us during the image annotation. And if multiple users are using it, then we can serve this same feature through an API so that it does not have to be run inside the browser. And as I have shown you here, even Roboflow does the same thing. So if you like move around your image, you will see it makes a network request and then generate the polygons. So I think it's the same idea that they might have implemented. So here it returns a mask, and then what I can do is I can take that mask and then convert those into contours. So basically this is a polygon which is processed from those masks, and we get this kind of annotation. I have yet to implement this thing inside my annotation tool, but this was just a quick idea implementation to see if it is feasible and how well it works. I think it works pretty well. So I will be working on to integrating this feature into the app. But for now, I just wanted to show you a demo about how this feature and everything works. And so far it works great. So I hope you enjoyed this small explanatory video about the point segmentation and how to utilize it for annotation. And there are a few more tools which are using this kind of feature. I think X label anything is one of those. I really like how it works, but it's an installable application, and my idea is that this is kind of like cloud native application, although it is running locally, and we can run it locally so that multiple user can interact with it, collaborate on the same dataset and projects, even if they are not located physically at the office location. Plus it gives us a very fast iteration on data sets if we want to train our own models. Basically we can write custom data loaders which directly reads from our database and then allows us to modify annotation real time as well as train models. That's my idea, and I just wanted to have a genuine application built so that I don't have to be dependent on Roboflow. Roboflow is a good website, but as a founder, I wanted to show our capabilities that we can also build some tools like these. So this has been under development from an year, and so far we have an annotation tool as well as this dataset management tool where we can upload our images as well as export and create versions of the images. So that's all for this video. I hope you really enjoyed it, and please do interact with the video. This really helps to boost the views as well as gives us motivation to make more such videos and demos.